Alright, hello everybody. My name is Michael. Welcome back to the channel. Hope you're having a wonderful day so far. Today we're going to be jumping back into Code Crafters, programming in C, building our own shell, episode 2 here. Should be a fun one. We're going to implement our own shell and continue on. After doing some thinking over episode 1, I realized that we might want to do some refactoring, considering the current approach we're doing via indexing on the tokens rather than tokenizing them into an array of pointers to the various string tokens. So I think we're going to try to refactor and implement that and continue on with the program. And that'll really help us to implement the rest of these features. It's fairly difficult to do this without that tokenization process in play. So let me turn back on that fan because it's hot. Should be fine. Okay, cool. So let's go ahead and get into this. So last time we left off on this part here, where we have these various type defines for our kind of our flags, or not, sorry, not type defines, but just define strings here, macros for flags for the various features of this shell. But what we're going to need to do is here we're going to implement this here, right? So as you can see, where we do this function stir c span, which goes through and finds the first occurrence of anything in our string here, and then replaces it with or finds the index of that value, and then we replace it. So what we can do is we're going to tokenize the strings here. So tokenize these strings into a token array of pointers. Okay, so we're going to have char star tokens is equal to a array, right? And I guess we'll set this equal to, well, these are pointers to various things, so we don't need to be super large, but I guess we'll just reserve 1024 space just for now. Okay, so we have char tokens, which is just an array here. And then what we're going to do is we're going to say while, and we're going to say char ch is equal to, but we'll say inside this while loop, we'll say char ch. We don't want to redefine this everything. I don't think we can do that. So let's do char ch here. Let's do ch equal to get char. I think get char is a function, right? I always forget. Let me see. Get char c. Yeah. Get char function is standard libraries used to read a single character here. Okay, so we can get char, and while we can do that, and while that value is not equal to would it be the null character? Or would it be \n? Well, we're replacing the new line index here with the first occurrence of a new line here. So I think it'd probably be a null character. So while get char is not equal to this, what we're going to do is we're going to start, or we'll say int start Okay, so let me keep a track of a counter. Let's say that. So when we enter the loop, we're going to set start equal to I. No, so we're going to have okay, is equal to I here. Okay, so we set starting to equal to I. This might point to the same place actually, so this might not be the right thing to do here. But if we say starting index equals to 0 here, I guess. Okay, and then we say the I is going to keep track of the index through our whole thing, right? Right, and so we can just set starting index is 0. Okay, so if the character is equal to just a space, right, we're going to set, if the character is equal to a space, meaning that we have come to the end of a word, we have a starting index, which is starting at 0 here. Actually, we don't even need, we just need a counter. We need some sort of lagging indicator. Actually, yeah, so I don't think we need this. Okay, so I will move forward on every pass. We do. So if we come up to a space, in the string, the next index is the start of the next token, right? So if we're in a space, or else if we're not in a space, we want to keep moving on. Okay. So then, how can we? Just give it a little warm up here. So if we're on a space and we have I equals to 0 here, which is going to be our index counter, which we're going to use to, well, maybe not even that either. We just need to save into tokens. Oh, so this will be our count. We'll say count here. Right, so this will be where we save into tokens as we increase. So if we equal to a space, we know that count gets increased, right, because we found a full word. And we're going to save that word in the next index. So then we're going to save. So count gets increased because, and so on the next pass, we save that address. And so what we're going to do is we increase count and we save the address. Count it. So let's map this out. I'm struggling here. Let's map this out. So we're going to get characters out of the string, okay, until it has the null terminator. If the character is a space, we know that we've ended a word, right? And so the next character is the start of a token, right? So on pass 0, we enter in, this is the start of a token, right? So if count is equal to 0, we will immediately save. I guess we can keep track of an I throughout this whole thing. And then when count in I is equal to 0, save. Right. Hey Tim, how's it going, dude? Welcome in, my man. I think about this the right way, you guys. Okay. So we enter into the string. We're looping over all the characters in the string. So right off the jump, we need to set tokens key of count equals to the address of current character, right? So that'll set the token but we don't want to do that every single time, right? We don't want to do that every single time. We want to then move on. So let's do this. If it's equal to a space, I suck. So right off the jump, we know actually that tokens key of count is equal to the first value in command buffer. Oh well, actually we're doing. Am I being dumb? Because we have a command buffer here which has all the values in it already. So can we just loop over the command buffer? Or should we not even use this command buffer and just do get char of the user's input until we, like this, and then have it saved into tokens? Right? Okay, so we're saying get char until \0. Well, the thing is get char, there's nothing to get char because user has already typed in stuff. It's already in command buffer. So maybe we'll say, because we have to save them into memory and then point to them. So that's why I think we're doing it this way first. Okay. So then we set tokens count, which is to start to it's 0, to equal to command buffer, right? Command buffer is just the first one in here. Okay. And then what we can do is if we have here we have count gets increased, right? Count gets increased after this, so now count is 1. Now if we have here, we're going to set increase count and then set the value. No, we don't want to increase count because we're saving at 1 here, not yet. So we already have increased count beforehand. So then we're going to set the value of address plus 1 for character, right? Okay. I suck. But we're not getting char because we haven't, yeah, so I don't think that this is right. So we'd have to say for, and let's use, rather than doing this, we can use pointers. Char p for p is less than tokens plus size of 24. I mean, that's probably not the best way to do it. So we will add to tokens, make sure p doesn't go beyond the pointer of the last value in tokens, right? And p++. So now we have a pointer here, right? And so what we're going to do is we are going to evaluate the thing is how do you tell if you're starting a word? So if you have a space, the next value is the token, right? It's the start of a token. So if the value at p is equal to a space, then what we're going to do is set the next value in tokens address also not the address at p because p is not here, so no, p is a pointer which needs to point to command buffer. So now p points to the actual characters in command buffer. So now what we're going to do is loop the pointer through each of the addresses in command buffer, and if the dereferenced value of the address is a space, then we're going to save into tokens at you save into at p. So I don't think we need this. Command buffer. Then we save into tokens, right, which is an array of pointers. We're going to save in there a pointer, which is going to be p plus 1, right, the next value. Okay, so we have tokenize here. This takes an array, make a pointer which points to the start of our command buffer. We're going to loop the pointer through until the end of no, it'd be command buffer. No. So we have I int I is equal to 0. This is our counter. So I is here, I plus plus. And we'll set this equal to some pointer, which will be p, right? Let's walk until p is less than, so we'll just say while p, while p is not equal to while the dereference value is not equal to \0, we'll say bool previous was space equals to false. So if this previous was space is true, previous was space equals true. How do you declare the start, though? Think of a tokenizer as maintaining two states, outside token and inside token. For each character, space while outside token, ignore. Non-space while outside token, say pointer, enter token. So a non-space character while inside token. Continue. Space while inside token, replace with that and leave token. Okay, so while p, the value is not the null pointer or the null character, the null terminator. I'm going to say bool in token equals to true, right? You're going to start off inside a token. So if in token and the dereference value p is equal to a space. So if you're in token and the dereference value is a space, right, you know that this token is over now, right? Because so we're going to set the value at p equal to we're going to set the value at p equal to the null character, right? The null terminator. So if we get to a space and we're in token, that ends the token and we seal it off here. Okay. Else if we're in token and it's not a character, or it's not a space, right? If we're in token and the value is not a space, then what we're going to do is set the value. So if we're in token and the dereference value is not a space, we're going to continue, right? We don't care. Okay. Else if we are not in token, can you do this? Right, we're not in token and the value at P is equal to a space, right? If that happens, okay, if that happens, so we're not in token and the value is a space, I think we continue as well, right? Else, if we're not in token, right, and the value at P does not equal to a space, then what happens? Right, if the value at P does not equal to a space when we're not inside token, then this is the start of a token. So tokens index of I plus plus is equal to P. So I think we don't need these two statements, and I think we can say else continue like this. So if we're in token and we have a space, we are null terminator. Else if we're not in token and we have a space, this is the start of a token. Any other scenario, we continue through the loop. So let's just role play here, I guess. On the first loop here, we're in token. Oh, hold up. We have to set this false somewhere, right? So if we set it here, right, we set this character, we're not in a token anymore, and we set this to false. Beautiful. Yeah, that would work if that's where we put it. Okay. So our command buffer, we're not going to do this. We're going to stir compare. We're going to stir compare tokens key of 0, right, for the command. Tokens key of 0. And we're going to do this. Okay, stir compare that. Put S. The value. So we're expecting a pointer, so we're going to put in tokens. Okay, so then what we're going to do is tokens. Okay, so hold on, what is it? I'm going to remove this part right here. Okay. Where my boys at? Hey, Kevin, how's it going? Polyworld prods down. No, again? No, it's still up. It's still up. I don't think I have a password reset on here anyway. Yeah, I don't have password reset on here yet. If you forgot your password, it's kind of screwed right now. I have it built in, but I haven't. I commented it out because I wanted. There was a bug, um, in it. I can't remember where it was. There was some like big security bug that I didn't think of, so I commented it out. um, um, hey Kyle, you mean to overwrite the command buffer? Okay, let me see here. Okay, so let's see. Undeclared identifier bool. Token. Okay, poop. I should say command not found. Shoot. It's tokenizing. We replace the \n. Stir C-span. And our command buffer new line index. Given the null, we overwrite the null terminator here. Meanwhile, the pointer is not equal to that. Wait, why does it do this? No. So you get S into command buffer, put it in there. Then we loop over all our tokens and make sure that this isn't equal to \n. Oh, shoot. Ah, crap. Yeah, this affects the data in the command buffer, which is fine because our tokens, those strings live in the command buffer, and then our tokens is just pointers to those strings in command buffer, the start of the strings in command buffer. So this way here will stir C-span. Search a string by traversing any characters that that just counts the number of characters before this happens. Let me set it to. Okay, so let's take this this here real quick. Let's see this improvement. We're not increasing P anywhere, that's why. Okay, so let's just do 4 P. Increase the P value every single time. Expression result unused. Expression result unused. Let's do. Let's see what happens here. Okay, so we're getting this command not found. It's not hitting any of these ifs here. Okay, so it's recommending to start with this as false first, right? And then if token, if not in token, if not in token and the value of P is not equal to space, then we know that this is the start of a token. Oh, I already have that down there. So here, if not in token, and we're a space, set in token to true, right? And we save token I++ equals to P. Okay, so how about that? I think, is that closer to what we're looking for here? Okay, so then it just suggests at the end of the loop to put tokens index of I equal to null. So we can loop then until we hit the end of the array, until we hit null in tokens. Like we can cut it off. We don't have to hit the end of tokens if they're not this many tokens worth, right? It can cut off early. So if we were to run this, help, whatever, command not found, echo, help, command not found. Crap. Sucks. How about exit? That one works. Oh, so that's right. It's matching spaces. We don't want that. If stir compare for this token is equal to echo, we'll put S. We'll go for char star p equals to tokens index of 1 while p is not equal to null, p plus plus, and then we'll just put S tokens p. Expects a pointer though. But then if we hit, okay, we could probably just do this then actually for every token. We could set token end here and then we'd know exactly where it is in memory. Because this is gonna, I don't think this is gonna work. So it's going, start of our token is help, H. It's printing. And then P gets moved forward. Oh, because it's moving forward in memory. That's interesting. So we wouldn't want to use a pointer. Okay, I see what's going on. It's reading out our initial thing. All right, it's reading out help. And then our pointer, our P here in this loop, is interesting. C is really interesting. This is really interesting. P is pointing to tokens index 1. When you move P forward, P is not going to point to tokens index 2. P is going to point to the next character that's housed at memory address token index 1. You just did pointer arithmetic to the next character in string tokens index 1, right? So what we need to do is set int j equals to 0 while tokens index j is not equal to null, right? We can increase j forward and we can put s j and we can print f, I think a space. Now that's going to print a new line in between each thing. So we don't want to do that, I don't think. Right, that's going to print out a new line in between everything, which isn't what we want. Okay, we're close. Right, so this put s is looping through You have to do that? Why can't you just print a raw character? Can I just print a string? We'll do a new line character here. Okay, so that'll, we just need a space, right? That's the only thing, is the space. Okay. I don't want to print a space at the end though. I don't think that this works, right? No. Print F. That doesn't work. Does work. There's definitely a space at the end here. Okay, so okay, cool. So we tokenize the characters, right? We have an exit function that works now, and we have an echo function that works now. So maybe we should print a space and then the character. So if you print a space, and well, no, because then it'll print a space first. Right? Can't. I'm sure. Echo help. Hello. Exit. Okay. So then, yeah, we just have a space. But we put it here. It'll print a space automatically afterwards every single time. If we put it here, we only get it at the end of the loop. If we put it at the end here, right, if we put it at the end here, we get the right thing, but I'm not sure if we're supposed to have a space at the end there. Let me take this echo function. Let's see. Is the space at the end valid? Okay. So we can either check if the next token exists, or we would have to print the first token and then print a space with trailing tokens. So we can do that, I think. Let's print F tokens index of 1. We don't need to say echo hello, it's just going to echo what we want, right? So we're going to say right, let me go, can we go back to the previous section? Or yeah, I don't think echo says echo back. I think it just says what we say. So then if we go j is equal to 2. Right, we're already printing 1, which is what we want, and then we can delete this. Okay, so let's try that. So if we say echo hello world, echo yo mama, Okay, cool. I think we are on to something here. I think we are doing, I mean, that took us a long time to refactor, but like the token, I thought that was gonna be a lot easier than it was. It doesn't look very difficult. It's only like, a few lines long, but I really had trouble with the logic. That's what I need to get better at. I think if I took like maybe a discrete math course or like one of those like Boolean logic courses in college that computer scientists usually have to take in order to help out with their conditional logic understandings, right? And really hone those down. Um, or I just need to make sure I just think about it in terms of, okay, what are my, I think a better way to do it is come at the problem thinking about it from what are all my possible, like, not edge cases, but like, what are my main scenarios that I'll face? Like, you know, like in this loop, if I'm in a token and I have a space, like you need to put together the logic combos and identify under what circumstances you're in and what to do with those circumstances. Okay, so I think that is good for our echo function. So let's go ahead and maybe take a stab at this type function. So an hour into the stream and we're just starting the type function, right? Sorry. Okay, here we go. So the type built in, remember, just determines whether or not the type of the given following token is a built-in type. So what we're gonna do is I guess we'll say if stir compare tokens index 0 equals to and our type macro equals to 0, right? What we're going to do is this is a type command, so we need to identify the token that was put in. So we'll say match or we'll say, sorry, not match case, it's switch, and see switch on the tokens index of 1 switch on tokens index of 1, okay, and we're going to have a case of match, or sorry, exit, echo, or type I think you do this for fall through. We'll say And then we'll put in as tokens. Next one. And we'll go. Every other case. Not found. And this will be not found. Tokens. Okay, let's try this. Ah. Okay, we need a colon after defaults. Switch statement requires expression of integer type. Char star invalid. Switch has to be a... So, that's annoying. Right? We can't use a string as our switch expression. It has to be an integer constant or integer type. So we need to now we haven't done C++ yet, Amaris. Thanks for the chat though. What's going on? How's everybody doing? Let me know what you guys are working on. Okay, so we can't do this. So I'm gonna take this. I'm gonna say ask a question. I have a question. I know that we can't do this because the switch, the expression needs to be int, not char star. So is it better to do if statements? I was trying to make it easily dynamic. Switch is generally the wrong tool for the command strings. How do you define like a hash set? See though. It's just... Okay, let's just do this. So basically you're gonna have a similar function to this, or similar expression to this, right? If strcomp tokens 1 equals to type, right, then what we're gonna do is printf to you're just going to printf to the corresponding %s and say is a shell built in \n. Okay, so that would do that. So we could just copy this down, else if, and then this just keeps happening. But for exit and for echo. So we'll also say here though, and right, we don't want the length to be too long either, right? Sorry, I'm dumb. All right, let's throw these guys here. Okay. Type echo. Echo is a shell built in. Type exit. Type. Echo type. Exit. Yes! Woo! I think we did it. Holy cow. Let's go. Hey Joe, how's it going? I had an interview for a tech lead position. The CEO interviewed me. He said my interview was not AI driven enough. That seems kind of like a common theme that we keep hearing about. So honestly, I really wonder, like if you had the balls, like, you know, if you just said screw it, like if you kind of were just, no one's really interviewing for memes, right? But if you really didn't need a job and you took an interview for kind of memes, if you got into the interview and they're like, okay, go ahead and go, like, right? You can, like, you know, whatever. If you just pulled up ChatGPT on your computer or Claude and just started talking into it and just started just prompting and just sitting back there, and then in between runs just talking to them about their day, be like, yo, what are you guys working on, what are some stuff that's cool, and then the run will finish and then you'll add on blah 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 blah, and you just prompt engineer it the whole time while having like a conversation about life with them. And I wonder how baffled they would be, or if that's what they want, like if you literally did not touch the code once in the whole interview and just said, this is what it is nowadays, apparently, right? Oh my gosh. Like you need, like if you didn't even touch your keyboard, like you just mic'd it and just. Okay, I think we're ready to try this one out. Let's give it a go. Okay, let's do Codecrafter submit on our type built-in. No. Line does not match. Showing space. Oh shoot. We got a trailing space. We still have a trailing space. Type invalid grape command. Why does this one always fail on me? What's wrong with this test? What's wrong with this test? Echo works. Oh. Wait, I thought I already had this. Oh. What happened to my other thing? I think we're missing a else statement down here. No, command not found. Oh yeah, this else stays out here. And then what we'll do is we'll just paste an else here. We need an else statement here. Sorry, I thought I already wrote it via that one, but it was outside the loop. And so we'll say, and it's such a similar prompt that it's kind of hard to tell. It's just not found instead of command not found. There we go. I think that'll work. Oh, what was that? Let's just run the test. Dude, what? Oh shoot, we did it wrong again. um, One more time. Woohoo! One more time. Boom, boom, boom. One more time. Let's go. Gotta leave some likes on that one. That's the type built in right there. Woo! All right, we did a lot there, right? So from last time we noticed that there was a bottleneck in our code for our shell is that we had some pre-existing architecture that wasn't really the right way to go about things and was causing us to really have some difficulty with finding out the different tokens in our individual command. And so what we did is we took the first hour of this stream to really go back through and try to do a tokenization process, right? Using pointer arithmetic to loop through our command buffer, flagging when we're in a token and when we're outside of a token, and then setting all the tokens as a pointer array. We do our normal comparisons. We just had to change over this from our command prompt indexing to just our individual token indexing. And then our type was really easy to do. It's just compare. Now, the only thing is right now, I already noticed that every type of function or every built-in we add, we're going to have to add another line to our type method. So maybe it would be easier, and I'm not exactly sure how we do it in C. I know in Python it'd be really easy to just say for whatever, if in built-ins, like a list of built-ins or a set of built-ins for O1 lookups, then then it's we can just use a simple string formatter to print out any of them for just one, and then we just have a data structure that houses all of our built-ins. Whereas for C, maybe we have to do it via struct, or I'm not exactly sure how to do it. We haven't got that far in the book yet for those types of things, as I don't really know, what would give us the quick lookups for the exact matches of something in a data structure via like a hash map. So, or a set, right? Anywho, cool. Let's mark this stage as complete and let's move on. Hey, moving on up to the same. Moving on up. Okay, here we go. This next task is the path environment variable. This is a medium difficulty task. Oh god. In this stage, you'll extend the type built-in to search for executable files using path. The path environment variable. The path environment variable specifies a list of directories where the shell should look for executable programs. For example, if the path is set to dir1, dir2, dir3, the shell would search for executables in dir1, then dir2, then finally dir3 in that order. Searching for executables. When type receives a command input, your shell must follow these steps. Check if the command is a built-in, like exit or echo. If it is, report it's a built-in, and stop. If the command is not a built-in, your shell must go through every directory in path for each directory. Check if a file with the command name exists. Oh god. We haven't really done file IO in C yet, so this might be a little difficult. So if the command is not a built-in, so in this else here, right, we must go through every directory in path for each directory, check if a file within the command name exists. Check if the file has executable permissions. If the file exists and has executable permissions, print command is full path and stop. If the file exists but lacks executable permissions, skip it and continue to the next directory. If no executable is found in any directory, print command not found. So we type grep. Grep is this. Type invalid command not found. Echo is shell built in. Okay. Okay. This one's going to be kind of tough. We haven't learned about file IO yet, so um, in this article, we'll learn how to operate over files using a C program. A single C file can read, write, move. File declaration. There's a file and then a file pointer. Okay. And then we can open it with fopen. And save the file pointer for that file in there. Okay, so it's pretty similar to Python then. So the thing I don't get though is it's saying that what is path? Okay, so we have a path environment variable. When a command like ls or Python is executed, a shell needs to know where to find the corresponding executable file. To do this, shells use the path environment variable. In this concept, we'll learn what the path variable is, how a shell uses it to find commands, and how to view and modify it. The path variable is an environment variable that contains a list of dictionaries to search for executable programs. Path is an environment variable that contains a list of dictionaries to search for executable programs. When a user enters a command that is not a built-in, a shell searches the directories in path for an executable file with that name. The directories in the current path can be viewed by printing the path variable. Notice that the paths are separated by colons. Each path is a directory where a shell will search for executable files. Notice, what does a path variable contain? How a shell uses path. A shell searches through directories in path from left to right. It checks the first directory in the list. If it finds the executable there, it runs it and stops searching. If not, it moves to the next directory. Since the shell stops at the first match it finds, the order of the directories is important. For example, if the system has two versions of Python in different folders, a shell will only use the one that comes first in path. What they're asking you is hard unless you read the documentation. You need to go to the menu page and search for struct dirent. This struct is the one used to store a file path, inode, and etc. Okay, so it'd be easier to do this if I was in Python, right? But we're in C, so we're having to do some stuff. So let's go to the manual page. And let's look up this struct dirent. The struct dirent is a C structure defined by the dirent.h header that represents a single entry file directory within a directory stream. It's primarily used with POSIX directory functions like opendir, readdir, closedir to traverse file systems. The structure contains the following standard and optional members. direct.h I'm pretty confused. Right, we just don't have a lot of the tools, I think, yet to know how to do what we're doing here. Okay, so this is a struct that has these fields, right? Functions or macros in this struct. Oh no, these are the members here. And these are things in the directory or in the header file. Huh. Okay. This usually means the program isn't installed or it is in a directory not included in the path. In which order does a shell search from left to right? New directories can be added to paths so a shell can find programs installed in custom locations. And this path keeps all the previous directories and adds the new directories at the end of the list. Okay, so for example, this. Most languages provide functions to check for executable permissions for a file, like OS access to Python. This path also includes directories that don't exist on disk, so your code should handle such cases gracefully. When parsing the path environment variable, remember that the delimiter, usually this or this, can verify operating. Okay, let's try to figure this one out. So, because we don't really know what we're doing, I'm trying to implement a path environment variable into my shell to be handled under the type built-in. I don't want you to write me any code. I just wanted to talk through how I could do this and what is path and how it implements into my current code. I've never used this before or heard of it before. It's a great point to stop and understand what's actually happening, because path is one of those things that every shell uses constantly, but many programs don't really learn until they write a shell. Imagine you're sitting in a shell and type ls. How does the shell know where ls lives? The executable is not magically built into the operating system. It's a file somewhere on disk. For example, for many Unix-like systems, bin ls or user bin ls, the shell has to find it. Okay, so path is an environment variable containing a list of directories. Conceptually, a colon is a separator. Okay. Environment variables. Path is not hard-coded. The shell inherits it from its parent process. For example, code $echo $path might print this. When your shell starts, the operating system gives your process access to these environment variables. So your shell doesn't create a path, it receives path. So then if we have this struct direct, Sounds hard. Your shell process inherits environment variables from its parent shell. You need some way to ask the operating system what is the value of path for my process. So we have to ask the operating system for the path. To retrieve the path environment variable in C, use the standard library function getEnvironment. So getEnvironment of path returns a const char star to path. Okay, so standard library, we have a getEnvironment variable function. Okay, so let's go back to here. If the file, okay, stop, cool. So here, here's our else. If the command is not a built-in, your shell must go through every directory in path for each directory. So let's go hashtag define path to be get env of path. Okay, so we have path. So this will be const star char. Well, we don't want to make it const because we want to append a path. So char star path is equal to this. So we say, so we have a path variable here, right? Okay, so we have path here, which is an environment variable to our path. We need to tokenize the paths, right? So we'd have char star paths, which is equal to, which is just an array. I don't know how many bytes to do, but whatever. So paths, right? So if I write, if we write a function called, okay, we call int tokenize, right? And it's going to take in a const char star command or string buffer, right? Or it's going to take in a char string buffer, right? And then it's going to have the I'm taking a pointer to that. So it's going to take in a const. Yeah, it's going to take in an array. So we're going to take in an array, and we're also going to okay, we're going to, and then we're going to take it, so a string buffer, and then a char star, a array of tokens, char star array of tokens, a pointer array of tokens. So then what we're going to do is do a similar process to this. Right, we're wrapping it into a function. So we're going to tokenize the strings. We have tokens is already in here. I is 0. Here's false. We're going to set the string buffer in token, in token, in token, tokens. Cool. And this is just going to return back I, which is the number of tokens, right? And so, yeah, it's just the number of tokens. So then what we can do, I believe, right, is we can delete this. We can call tokenize int I equals to tokenize and we're gonna tokenize, and we're gonna pass in the command buffer, and we're gonna pass in tokens. Okay, that should tokenize those still. So let's see if we're working still here. Okay, that's still working. Good. Nice. So maybe it's, let's see, character right here. Okay. Okay, so now we have our function tokenize, which we can reuse, given a string buffer and an output of tokens that you want, right? So what we can do is we have paths here. What we can do is call, this is a, point to the start of an array. Yeah, we'll take in a pointer to the start of an array. We'll take in a pointer to the start of an array. So this should still work, hopefully. Nice. Okay, cool. So we have our function tokenize that still works. Now what we can do is, because the array and the pointer are the same thing for the first value, we can substitute that there. So that's why that works still. So what we can do now is we can just pass in tokenize into here, calling the string buffer, which is going to be path, and we're going to pass in paths here. And this is going to give us how many paths in path count, or we'll say dir count, right? And so what we can do is we'll say printf, we'll just put into here %s for the path, and then we'll also put in here, we'll say path here, we'll say path count, dir count, and we'll put that here, which will be %i, and then we can put in our paths or dir count here, and then let's run this. Got me. Fool man can't get fooled again. There's our path. Sweet. Michael Deming, MVM versions, node, library systems, cryptos, app, bin, user, blah, 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 blah. Dir count is 1. Oh, so we need to also adjust our tokenizer function to have a delimiter. Right, a delimiter, which is going to be a char, right? And what we're going to do is, instead of saying this, we're going to put the delimiter. Everywhere we have this string. Okay, so then what happens is we need to pass into tokenize a delimiter of here is going to be the colon. And here in this tokenizer, the delimiter is going to be space. Let's see if that works. Beautiful. I think that worked now. If I go. Nice. Now we go echo, type, type, type. Nice. Okay, cool. So I think that's working good now for our tokenizer. So now we have our path that's extracted out here and tokenized into our paths array here, which is good. So now what we're going to do is we have our paths here. What we say is check if the file with the name exists. Okay, so let's see here. I'm going to take what we have so far and our output that we got, and we're going to do a little checkpoint check here. Okay, so we have a string. So we have a directory count via the tokenized function here. We get the invariant, which is a pointer to path, and we have an array of pointers, paths. What I want to do is I want to tokenize, or maybe I don't want to add anything to the end of those. Okay, so what we'll do is we'll have another parameter in tokenize for add. Can you put a boolean in here? So like we'll say true for this thing here, tokenize on this spot true. So here this will be, or false. And so in the tokenizer, this will be for swap spaces. So here, you could say if swap space, then you do this, right? I set it to false. So else then token true, increase forward. So you would do, if your swap space, you would set the pointer to be the no, so you just do the swap. You don't have swap space, you're on the space, right? You're on the space. Maybe not. Maybe that's a dumb idea. Okay, so how can I copy the path variable rather than the pointer to it? What I don't get is the how. One backslash zeros. Tokenization, you do want this. Your strings must end in matches. It's the whole trick. In path, you also want this. Real problem you're running into. You're not actually trying to get rid of this. You're asking why it is printing. How to safely iterate path tokens without accidentally breaking your original buffer or losing references. Okay, so we would just do every I think I'm going to take a break here. For C, you can use macros. if def win32 define pathless separator. Developers don't always fill the test with path variables. So we have our path. So I have my paths. Now what? Now you move to the next stage. Okay, so we have a bunch of paths, and we need to make sure that they're equal to a potential path for this command. So let me see here. So we have this, else, right? If check if a file with a command name exists. So we need a const, or we have a char star subpath, or we'll say check path is equal to so this would be our in our directory. user/bin/grep. For each pass I build a candidate path. For I So we're going over all the dir count. We're going into paths index of dir count. Or sorry, index of m. Right, this is the string for the directory. We're going to add to it a / and then add to it tokens index of 1. This is going to be our char star path, like so. So then what we can do is if we'll do stir comp if stir comp we're going to compare the strings of temp path and Oh, the fan. I see that. The shadows make it look like a huge fan going. What's your shell gonna be called? I was thinking Shelly. I like Shelly. Okay. So, what are we doing here? We're making a temporary path in which a temporary string which resembles the file, right? It's the path plus the command. So, okay, that makes sense. So that's our temp path, and we're going to compare temp path with for every directory in there, right? The thing is we don't have the ability to. How can I get the file names each in the dir? You're making two different ideas. You're going to separate them cleanly. I want you to manually list the files in path and compare names. That's not how shells normally work. You do not list files in a directory. This line of thinking, get file names, is not necessary. Why? Because path lookup is not scan directory, list files, compare strings. Instead, it construct candidate path, test if it exists, plus executable. Okay, so we're just checking if stir comp um, equal to paths index. Well, this is just our paths. You cannot concatenate strings with plus and say that's the point of string build. Combine. How do you combine them into a single string? How do you combine them? How would you? Is there stir? I think there's a stir cat. Yeah. Okay, so we're gonna do temp path of stir cat. We're gonna append the string paths. We're gonna add one to it. So we're gonna concatenate. This. One. And then we're going to stir cat again. On two. Like this. So if stir comp temp paths and so we're going to make a path. We're going to make a path here. Then we have going through all the directories. So we want to open this file. So we want to go file, so file, go to F open the temp path. So this is char star, no, char temp path. I'm gonna open the temp path in read mode. If file pointer no this file, I think we do this, else. So the file exists, print this path and the command is full path. Else print F saying tokens 1 %s is %s, pass in the tokens x of 1, and we're going to then pass in into this one. This is the path, so expected expression. Expected expression. So I think it's because this else is not expecting a for loop. So if I get rid of this, and we say here, this is going to happen automatically now then. This isn't going to work with this else here, right? Let's get a checkpoint check here. Checkpoint check. Oh, whoops, sorry. It's this. That's why it wasn't working. Stir cat returns a char star. Okay, so this is a char star temp path. And we'll open. F open just takes in a string, so we'll open the dereferenced value of path, temp path. Boolean here. The file pointer isn't null, I mean we have found a file. We'll print this value. Else we'll continue. Right? And this is not found if nothing was found. So if this not found. So I don't think this is gonna work either. Incompatible integer to pointer conversion passing char to parameter type const char. Okay, so it does take a pointer into that path then, not a dereferenced value. Trace trap main. Okay, let's see here. Let's do a checkpoint check. Let's stir TOK underscore R. C's function names are so garbage. Stir TOK underscore R. What the hell is this? Split string according to given number of delimiters and returns the next token. For splitting a string by some delimiter. Splitting a string is a very common task. Stir talk? What are these names? Okay, so let's maybe say concatenate. So we need to have paths be so tokenize is okay, so we need to basically copy the path okay, into its own variable. So we're gonna have char star path copy is equal to stir cat into path copy is a pointer. A path copy is equal to is an array size 1024. We then go stir cat path copy. What's stir duplicate? There's a lot of functions we don't know, I haven't learned yet. Okay, so we have what we're doing here is we're saying found is false. We're looping over every directory. Creating a path by concatenating paths index of m. Oh my god. C is so hard. Python, this would have been so much easier. Queso. I'm almost gonna be done for the day though. I'm fried. Okay, so we concatenate paths index of m. It's not work. Let's see what we got so far. You're very close, but there are a few critical C-level bugs that will break your shell. Your path copies undefined behavior. Path copies uninitialized. Garbage memory. Stir cat requires a valid null terminated string first. Our temp path. So it wants us to instead use an array as temp size 1024. This is an array of characters, right, for our temporary string. What's s and print? Prints the string stored in the buffer and character count. That uses to print the specified string till a specified length in the specified format. Oh my god. Who writes this garbage? It is defined in the standard.io.h header file. A specified format. Writing %s onto buffer with capacity 6. Writing Geeks for Geeks. Buffer. Onto buffer. The capacity of 6. So it also prints into a buffer array. So we have our temporary path here. Want to use our SN printf to write into this buffer temp path a size of, we want to do size of the temp path. We want to fill the temp path. And what is this third argument? Format. String C string that contains a format string that follows the same specification as format in printf. Okay, so this is the print that's going to take place. A part of this save and print. So we have format is going to be for the string to print %s over %s. A string over a string, and we're going to insert paths m, the directory we're on in paths, and we're going to insert the token index of 1, the command. So it's printing out the created string basically and saving it into temp path. Then we have file pointer open temp path in read mode. We then if file pointer is null, we do this. But then a key thing we have to do after this, right, that I wasn't anticipating, is we have to close the file. Usually we use the with constructor in Python, but in this case we do fclose. You close the file pointer. You say we found a true type here, and then we break out of the loop for this for loop early because we found one early. And then we have this. And at the end of this, no matter what happens here, we continue, right? At the end of, no, outside of this for loop here, there. Okay. What's wrong here? Okay, so we have if this, or we can clean this part up. If this, or this, or this, So if it's type, right, if this or this or this is true, then print this. Else, we'll set Boolean to false for that we found a directory that matched, or found a file that matched this directory. We say, we loop over all our directories. We create a temporary path where we're going to copy all of the values of path M I don't get this part. So S and save and print F, right? Is that what it stands for? Is that what that stands for? Let's see here. Here's all like knotted. It's really annoying me. It's like bunching up and like getting caught. Wow, my hair's crazy. Hey, what's up, Super Me Overlord? Supreme Overlord. I think. Save printf. For example, sprintf, you could make a char buffer usually on the stack. And then sprintf. How's it going, Swain? Hey, Mac J. How's it going? Yeah, we still grinding here. Okay. So path copy is uninitialized here. Expected expression. You have to wrap it. Hold on, all these colons are giving me a headache. Where does this open? This is for the while loop. My gosh. So what's this one for? I hate this. This is for the type. Found. I'm having struggle with these layers. Okay, so bool found false. For loop here. Below that, char sn print file, if file print, this closes the if statement, this here's on the if, what the heck? I'm so confused. Gotta zoom out. Okay. So close this while loop. So that's how the while loop closes there. Turn 0. So we want to continue here. Crap, I suck. So if not found, printf. Else. No, we don't want to do this. I don't know why I'm struggling with this. I'm like, can't get the order in my head here. It's the continue. Only the printf is inside the if statement. Okay, so what we want to do is open this and continue everything here. Right? And now always run to make sure type logic, everything below. Type is currently. This is so stupid. Type equals 0. If this. Or this. Or this. Printf. Continue. Like so. So we need to continue in this if scope here. Bool found. For file char if null pointer break. Perfect. Those guys back up. Nice. If here found. No. If that handles this, that goes out here. Continuous happens here. This goes away. Okay, so if we do this. If not found, then we're going to printf. Else we're going to continue. Echo, wait, run, if I go here, okay, I think I'm done here for tonight, you guys. This will wrap up episode 2. I suck at. That's the problem with C is when the code starts to get long, all these if blocks start to get. It's just all. That's the thing with C is it's just logic. It's a lot of just logic checking, and like in Python, it's all a little bit packaged a little bit better for you. So you just get a bunch of like ifs nesting here, and it just sucks. So if you guys need advice for how to write longer C programs that don't just get a bunch of logic and a big overarching loop that you can't even figure out where the brace associates with it, that's what I'm struggling with here. All right. Thanks so much for being here, you guys. I appreciate you guys joining me for episode 2 here of building my own shell in C using code crafters. Write your own shell. Thanks so much for being here. I'll be back in tomorrow. We'll continue on, and I'll see you guys in the next one. All right, you guys. Peace out.